So now we're going to get into the hardest type of radical equations, and that's when we have two radicals in the same problem. So basically what's going to happen here is because we've got these two terms with radicals, that once we square both sides and we end up with a middle term, we're still going to have another radical left in the problem, which means we get that thing by itself and square both sides again. We're basically going to have to square both sides twice. Now, while it's not a mathematical necessity, I do have a suggestion for you, and that's what you want to write down here in your notes, is that whenever there are two square roots in an equation, like this problem here, you should try to get them to opposite sides of the equal sign. And again, this is not a mathematical necessity. It's just going to make your life an awful lot easier. Because if you try to square both sides right now, the middle term that you get, the 2ab term, would be disgusting because you had these two radicals forming the 2ab. But by separating the radicals, your 2ab term is going to be a little more reasonable. So let's look at what's going to happen with that. Let's go ahead and subtract the root 2x to the other side. Now that we have them separated, now we can square both sides. And because we're squaring both sides, we need to make that note to ourselves that we better check any answers that we get. The left side is the easy side to square in this case, because we're just squaring a square root, so you just get the stuff underneath. But on the right-hand side, this is where we have two terms. So because we have two terms, we're going to do the a squared, so we're going to square the first term. Then we're going to do the 2ab. So remember that when we're multiplying radicals, that 2 is outside the radical. So I'm going to write it up here, for the 2ab, we have 2 times 3 times negative root 2x. Outside the radical, I have 2, 3, and negative. That makes negative 6 root 2x. And now for my b squared, I'm squaring the root 2x, so I just get 2x. So now I still have a radical in the problem. I don't want to square both sides yet because the radical's not by itself. So I want to start moving stuff around until I have the square root by itself. So the first thing I would do is subtract 2x from both sides, which is kind of nice because those x's completely go away. I get 5 equals 9 minus 6 root 2x. I'm then going to subtract the 9, getting me negative 4 equals negative 6 root 2x. Now I could go ahead and divide both sides by negative 6 before I square both sides, but that's going to introduce a fraction in my problem. I don't know if I want to do that. Now I do notice that both sides are even, so maybe in this case what I'm going to do is divide by negative 2. That's going to leave me with 2 equals 3 root 2x. Now we're going to square both sides again. We don't need to right check your answers again because we're already going to check whatever answers we get. 2 squared is 4. And now we want to be careful about how we square that right side. We need to square the 3, which gets us 9. We also need to square the square root of 2x, which gets us 2x. So we're looking at 18x on the right. If we divide both sides by 18, we get x equals 4/18 or 2/9. We still need to check this answer of 2/9, so we're going to come all the way back to the beginning and check x equals 2/9. So 2 times 2/9 plus 5 inside the radical plus the square root of 2 times 2/9 is supposed to equal 3. So we have the square root of 4/9 plus 5, and instead of 5 I'm writing 45/9 because I know I need a common denominator, plus the square root of 4/9 is supposed to equal 3. So I'm going to get the square root of 49/9 plus the square root of 4/9 is supposed to be 3. So that's 7/3 plus 2/3, which would be 9/3, which is in fact 3. What that tells me is that x equals 2/9 is in fact the correct answer.